Okay, guys, section 9.4, the elimination method. Now listen, what we've been talking about is substituting, right? We've got two equations. We get a variable by itself, and we can throw it into the equation, yeah? But when we do that, aren't we getting rid of one of the variables? I mean, isn't that the idea?
Yeah.
Right? Here's another way that we can get rid of one of the variables, but it's not substitution, okay? Let's look at these two equations. And I like, at this system, I like that they have them on top. They're set up one above the other, okay? Normally when I'm doing substitution, I like to put them side by side, but with elimination, I like to have one above the other. Do you guys see that y, what's the coefficient of the y's? Or what are the coefficients, I should say, of the y's? Miles?
1 and negative 1.
1 and negative 1, right?
Yeah.
So let's think about those two numbers for a second. If I were to add 1 and negative 1, what do I get, Devin?
0.
0, and 0y would just cancel out, yeah?
Yeah.
Okay, so when I'm looking at these equations, if I've got two variables, well, not two variables, but the same variable in two separate equations, and they have the same absolute value, right? Not the same sign, but one's 1 and one's negative 1. Then I can combine the two equations so that one just disappears. I can either subtract them so that I get 0, or I can add them so that I can get 0. So when I'm looking at this one, do I want to add these two equations together, or do I want to subtract these two equations from each other? Gordy?
Add them.
You want to add these because they have opposite signs, right?
Yes.
And I always do them in columns. Do you see why it's important that we know what standard form is?
Yeah.
Do you see? We've got x's to the far left, we have y's, and then we have numbers on the other side, because they line up together, because we can't add them if we don't have like terms. So we need to have them in the same order all the time. So, standard form. Austin, what do I get when I put the x's together?
You get 7x.
I don't think so.
Or 2x.
I like 8x when we're adding.
Oh, right. Sorry. I was thinking.
Good morning. How are you? How was your weekend?
Pretty good.
Okay. All right. All right. What if I add negative y and positive y? What happens there, Chris?
They cancel.
They cancel. So you know what? I'm not going to write anything there. I'm just going to cancel them out like that because they've gone away. Okay? I'm going to put my equal sign. 12 plus 4, Devin? 16. Divide both sides by 8, and x equals 2. Is that easy enough, Ruben?
So yes.
Do you like that? Ruben, how do I find out what y equals? What do you think?
You put it in another form.
Not in another form. What am I going to do? Whenever I want to find y, what do I do?
Put it in standard form.
I don't need it in function form. Whenever I want to find out what the other variable is, what do I do?
Oh, put it along.
I just plug it in. So I'm going to pick one of these equations. I'll just say 5x minus y equals 12.
5.
And I'm going to plug in the 2 for x. So I'm going to get 5 times 2 minus y is equal to 12. 10 minus y is equal to 12.
5 is equal.
Not 2.
Oh,
Negative 2. When I subtract 10 from both sides, I get the opposite of y is equal to 2. So y has to be negative 2. So what's the ordered pair that solves this system? Miles?
2, negative 2.
2, negative 2.
Okay.
Okay? Let Miles have his chance. Questions about that? Yeah. What you got?
When you know when to add or subtract.
If they're opposite signs, adding makes them cancel out. If they're the same sign, then subtracting makes them cancel out. So since I had negative 1y and positive 1y, I wanted to add them because that's what would give me 0. Yeah, CB?
We didn't have to do any of that, right?
I'm sorry?
We didn't have to do any of that.
Well, we needed to find out what y was. So we did have to do that. Yeah.
So the
Yeah.
answer is 2, negative 2?
The answer is 2, negative 2. That's the point that solves that system. If I were to graph it, where do these two lines intersect, Miles?
At.
It's not a trick question.
2, negative 2.
2, negative 2. That's where they cross each other. Devin?
We can't use this method unless they have the same absolute value.
You know what? Today I'm giving